Alright, so here's the video for the second day. The second day we're going to be talking about exponents and evaluating expressions. And what I want you to learn out of this is that there are going to be some different type of exponential situations, and the importance of these three O's or order of operations. Alright, so here's the basics. We're going to pause this. You guys are going to write this down. Basically, an exponent tells you how many times to multiply the base by itself. And you're going to have four different types of exponent examples today: positive bases, negative bases, exponents whose bases are negated, and zero exponents. So let's go into exponents with positive bases. These are things that you guys have seen before. So the exponent tells you how many times to multiply the base by itself. And the base is everything that the exponent is touching there. So since it's a 2, we're going to multiply the 2 by itself 4 times because the exponent is 4. So we have 2 times 2 times 2 times 2, which gives us, 4 times 4. I'll show my work, which is 16. Over here we have m raised to the third power. Now m is a variable, but we have a hint here. M is equal to 8. So this is kind of like the transitive property that we learned yesterday. We're going to substitute in the value for m. So instead of m to the third power and just get m times m times m, I'm going to do 8 to the third power, which is equivalent to 8 multiplied by itself 3 times, which is equal to 512. 64 times 8, 512. All right. Next, I'm going to ask you to do the u-try. So the u-try is your example. So pause this, and you're going to evaluate. Here you have c raised to the fourth power, and up here it looks like c is equal to 3. Make sure you show all your work because that'll be checked in your notes. Now, the next example we're going to do the example when the bases are negated. These two right here are the ones that get confused the most. We have bases that are negated and bases that are negative. What the big difference here is, in this example down here, are bases in parentheses. So the 4 here is actually all of this raised to the fourth power. But the 4 up here, since the negative is not inside parentheses, the 4 is only with the 9 as a base. The 4 is only the exponent of the 9 as a base. All right, so this one is the negative of 9 to the fourth power, or I like to write it like this: negative 1 times 9 to the fourth power, or negative 1 times 9 times 9 times 9 times 9, which is, we have negative 1 times 81 times another 81. And 81 times 81, of course, is 6,561. So our solution here is going to be negative 6,561. All right. Over here, this one might be a little bit of a smaller solution to follow. But if you can see it already, this negative here is not actually associated with the base itself that's being raised to the exponent. If you think about this, if you had like 3 minus 2 squared, you would do the 2 squared first and get 4, and you would have 3 minus 4. So you didn't do anything with the minus sign when you squared the 2. That's the same kind of thing that's going on over here, except there's no number in front of the 2. So this is kind of like the negative of 2 raised to the fifth power, or negative 1. I like to put the negative 1 there because I just taught you that property, multiplicative property of negative 1, and it's kind of like it is there, times 2, and then this times itself 5 times, right? 2 times 2. All right, and if I did all that work, I would get negative 32. Okay, now here's different. It's exponents whose bases are negative. So the whole base is negative. So this, when spread out, looks like negative 9 times negative 9 times negative 9 times negative 9. See the difference between the two? And then that's actually a positive 81 times a positive 81, and that gives me a solution of a positive 6,561, because it's negative times negative, positive, and negative times negative, positive, so it's positive times positive. Same thing applies over here, but instead of the situation where we had up top, our base is negative 2, so it's not the negative of 2 raised to the 5th power, it's actually negative 2 multiplied by itself 5 times. So times negative 2 times negative 2 times negative 2 times negative 2. My handwriting is terrible today. And in this case, since it's an odd power, we're actually going to get the same solution. But you have to be very careful for these two because they're the ones that students mess up the most. Okay, I'm going to have you do a couple U tries here. Your U try 2 is f raised to the 2nd power, and your U try 3 is the negative of e raised to the 3rd power. So pause it, try those examples, and I'm going to move on. All right, now I'm going to move on to 0 power exponents. 0 power exponents are bases who are being raised to the 0 power. So any number raised to the 0 power, hopefully you know this, is 1. Here we have this entire quantity being raised to the 0 power, so this is 1, because any number raised to the 0 power is 1. Over here, this is the negative of 9 to the 0 power, so this is another one of those tricky ones, because what's being raised to the 0 power is just 9. So it's the negative of 9 to the 0 power. This one is actually equal to negative 1. And then here, if you have an entire sum, and all of it's being raised to the 0 power, we can just conclude that that is equal to 1 as well, unless we have some stuff on the outside. Okay? All right, so now we're going to go into evaluating exponential expressions with substitution. And we already did this, so I can roll right into it pretty quick. This is going to ask me to evaluate a to the 3rd power if a equals 3. So this is just going to be 3 times 3 times 3. And that's going to be 9 times 3, which is 27. The more work I see on a piece of paper, the less likely you are to get something wrong. So if you have to do a couple of these first and show your work over here and slowly get your way to the answer, that's way better than trying to do it in your head and getting it wrong. Now, an expression is anything that does not contain an equal sign. So this is technically an expression. It has more terms, no equal sign, but we can still evaluate it with substitution. So a squared, or 3 raised to the 2nd power. And when I substitute, I like to put it in parentheses, especially if it's negative, plus b squared. So b is a positive 4 squared. And I'm going to do this first. I'm going to do the 9, and I'm going to add 16 to it. And there I'm going to get 25. So pretty much you should be pretty good with this stuff as well. If not, you can go back and rewatch that. All right, now they're going to get a little more complex. Here we're going to deal with some of the negative bases. Now when c is equivalent to negative 2, c is equivalent to all of negative 2. So if I'm raising c to the 3rd power, I'm raising all of negative 2 to the 3rd power, which is not the negative of 2 to the 3rd power, but it is negative 2 multiplied by itself 3 times. And that's going to give me a positive 4 times a negative 2, which is going to give me a negative 8. Down here, it's going to get a little more complicated. My c value is negative 2, so I'm going to rewrite everything and just put in parentheses what I'm substituting. So the negative of negative 2 raised to the 2nd power minus 3 plus, and a is a positive 3, I'll still put it in parentheses, 3 squared. I'm just going to work my way down here. I'm not going to do this first because exponents comes first in order of operations. So it's going to be the negative of negative 2 times negative 2 is positive 4 minus 3 plus 3 squared is 9. And then I can put these together and I get negative 7 plus 9, and that gives me a positive 2 value. Here I have 4 raised to the a power plus 3 times c, so I'm just throwing a little curveball at you where the exponent is what you're substituting. So it's 4 raised to the 3rd power, and you can use parentheses up here. So that's 4 times 4 times 4 plus 3 times -2. And when I raise 4 to the third power, I get 4 times 4 times 4, which is 64, plus a -6, or 64 minus 6, which is 58. Okay, now I got a few U tries for you to do, and that's the end of the video. So pause it, just be really careful. I'm probably going to try to trick you around things like question number 5 and maybe question number 6. All right, if you have to go back and rewatch any of that, feel free. And that's it.